Hey guys, so we are going to do a practice problem, and I realized this is typed in wrong. This should be 309. Okay, so we are going to do a practice problem. I'm going to try to write the stuff on the screen. I kind of suck at writing on the screen with a mouse, so sorry. For chi-squared, remember our formula is going to be observed minus expected squared divided by expected, and it's the sum of all of those added up. So for our practice problem, suppose we are classifying defects in furniture produced by a manufacturing plant based on the type of defects in the production shift. A total of 309 furniture defects were recorded, and defects were classified as A, B, C, or D, and at the same time, each piece of defected furniture was identified according by the production shift. So what we are going to do is we are going to try to figure out if one shift had a statistical significant difference in the amount of defects over the other shifts. So if I had 309 total defects, I would expect there to be 103 defects per shift because there's 3 shifts. 109 divided by 3 is 103. So I'm going to pause, go through, and add everything up for how many total defects there were per shift. All right, so I add them up. So shift 1 had 94 defects, shift 2 had 96 defects, and shift 3 had 119 defects. So it's looking like shift 3 sucks. But we're going to see if that is a statistical significant difference or not. So our HO, our HO, going to be that there's no difference between the defects in those 3 shifts. So we are going to run the chi-squared numbers now. All right, so if I do the chi-square, my first one would be observed. We had 94 minus the expected, which is 103, squared divided by 103. And then we are going to do that for the next 2 shifts. All right, so if we do the rest of them, the next one would be 96 minus 103 squared divided by 103, and then 119 minus 103 squared divided by 103. So those are our 3 shifts. So down below, I'm going to extrapolate out the math. So take a minute and do that yourself. All right, so if we add all those numbers up, okay, we get 0.79, 0.48, and 2.49. So now we're going to add those up going across. And I just rounded to the hundredths place. So 0.79 plus 0.48 plus 2.49 is 3.76. That was a good burp, man. Okay, so 3.76. So for this example, because we have our 3 shifts, our degrees of freedom is going to be 2. So if I go over to my chart, so degrees of freedom is 2, I'm going to go over to my 0.05 confidence interval. Oh, hang on. Let me pause. We're back. So we're looking at that, and what we got, 3.76, is below 5.99. So that means that we have to accept our null hypothesis. And even though it looks like third shift is doing a bad job, it's not a statistical enough difference in the amount of mistakes that they're making. So that is our little warm-up example. And now what you guys are going to be doing is you are going to be doing a lab about chi-squared with M&Ms. Okay? So you are going to read through this lab, please. And then there should be a large bag of M&Ms in the classroom. Every group, so if you guys get into groups of like 3 or 4-ish, Every group take a big scoop of M&Ms out of the bag, or if you just want to divvy up the bag between all of the groups, that's totally fine. When you guys are done with the lab, you can eat the M&Ms, not a big deal. So this is information from the M&M website of what percentage of M&Ms are each colors in our milk chocolate M&Ms. So those are our expected values. So once again, our null hypothesis is that there is no statistical difference between the amounts of M&Ms that would deviate from what Mars Candy Company puts out there. Okay, so that is what we expect. So what you are going to do with your M&Ms is you are going to write down how many M&Ms you observe of each color in your group and how many you would expect based off of those percentages. So you might not get even round numbers, and that's fine. You can put decimals down there as well. And then you are going to fill out this chart and figure out if in your little sample size there is something statistically weird going on. Okay. But because the bigger sample we get, the better it is, you are then going to read through this and you are going to figure it out for the entire class. Okay. So on the side whiteboard, I want every group to write down how many M&Ms they have of each color. And then you guys can divvy it up and figure it out with all of your groups of doing it for the whole class or like the whole bag of M&Ms to see if those get closer to being not as statistically significant, or if there is some tomfoolery going around at the M&M factory. You never know. Okay. And then what I would like you guys to do are the practice problems at the end. And that is all that you guys are going to be doing for today. Next class, you guys will have a chi-squared quiz. So please make sure to go through all of this stuff. This is also a really good day to like kind of get caught up on some things. And next week, maybe if you're good, I'll come in and do a lab with you guys. But we'll see. We'll see how she is. Okay. So have fun today with your M&M lab and see you later, alligator.